Good day, students. On this clip, we're going to be going over two examples on how to find inverses and verify that our answers are in fact correct, okay? So let's go ahead and write down the instruction for the two examples. So we're to find the inverse of the following functions and prove that your answers are correct. That your uh, answer, your answers are correct. Okay? All right. So let's take a look at question number one. We have the function f of x equals 3x plus 5. So the task is to find the inverse of this function and then prove that our answer is in fact correct, okay? So part one of this three-part proof is to find find f inverse of x. F inverse of x is the inverse of this function. All right, so how do we find the inverse? So to find the inverse is a two-part process. We're going to rewrite actually, switch, and then solve, okay? So to rewrite, instead of f of x, I'm going to write my function as y equals 3x plus 5. Writing it in this form makes it easier to switch, okay? So you rewrite first. Now we're going to switch the x and the y's, which is what inversion is all about. So we have x equals 3y plus 5. All right, so after switching, we're going to solve for y, and y will be our inverse. Okay, so to get y by itself, what we're going to do is subtract 5 from both sides, and then divide by 3. All right, so let's go ahead and do that. So we subtract 5 from both sides. Now we can switch this equation around while we add it using the reflexive property of equality. So we can have 3y equals x minus 5, and then divide both sides by 3. Divide by 3, divide by 3, and then we'll have y equals x minus 5 over 3. Okay? And this is the inverse of f. So f to the negative 1 of x equals x minus 5 over 3. Now, is this inverse correct or no? Now, to determine if our inverse is accurate or not, we're going to use a two-part process to verify that our solution is in fact correct. So this is going to be part two of our problem. So for part two, we're going to show. So write this down. Show that f, the original function f, composed with its inverse, f inverse of x, equals x. Okay? If we can show that this is correct, we'll move on to part three and show that the reverse composition is also true. Okay? Is it also equal to x? All right, so let's see if we can show this. So underline it first. All right, so for this one, we're going to start out by writing down what the outer or the parent function is, okay? So we're looking for f composed with f inverse of x. So the parent function is f of x. So let's identify what the parent is. F of x is 3x plus 5. Now this parent function is going to receive an input function, which is the inverse, f inverse, right here. So to get it prepped, we're going to replace the x's with parentheses. So f parentheses equals 3. Now I'm going to replace this x with the parentheses as big enough to accommodate the size of this function. So let's make it like this, plus 5. All right. Now the name of the input function is f inverse. So we put that on the left side. And the value of the f inverse, which is x minus 5 over 3, that goes as the input on the right side of the equation, x minus 5 over 3. Okay? So let's simplify this and see if we get x as our final answer. So looking at this, we can divide by 3. Divide this by 3. 3 goes here, 1. 3 goes here, 1. So that equals x minus 5 plus 5. And then 5 and 5 add up to 0. It would add up to 0, so our final answer is x. So in this case, we see that f composed with f inverse of x equals x. So that is excellent. So this part is good. So the next part, we're going to try and show that the reverse composition is also true. So what we want to show in this part right here, let's make it broken. What we want to show in this part right here, for part 3, show that uh, f inverse composed with f of x equals x. We will just reverse the order of the composition here, and we want to see if that's true also. Okay, so that's the next part of the proof. All right, so let's go ahead and show this. See if this is true, or we can show that this is true. So what we're going to do first is write down the parent function. The parent function is f inverse of x. How do I know that that's the parent function? Because it comes first, okay? So the value of the parent function is this result we got here, which is x minus 5 over 3. Now what we're going to do next is get this inverse function prepped to receive the input, which is f. So to do that, we're going to replace the x's with parentheses. So we're going to have f inverse parentheses equals, now the parentheses on the right should be big enough to accommodate the size of f, which is 2 terms right here. So parentheses, this should be big enough to accommodate that, minus 5, and this whole thing divided by 3. Okay, now the name of the input function is f, so we put that on the left side right here, and the value of the input function, which is f, is 3x plus 5. Okay, so this is what it means to compose two functions. You plug one into the other. Now let's simplify the right side of this composed function and see if we end up with x. All right, so we have, this is going to become 3x plus 5 minus 5 divided by 3. Okay, these two 5s cancel out, and you have 3x divided by 3. 3x divided by 3 equals x, because these 3's divide. And that tells me that f inverse composed with f of x is equal to x. So that checks out. All right, so part 3 holds. So what's our conclusion? Well, since f composed with f inverse of x is equal to the reverse composition, which is f inverse composed with f of x, since these two are equal to x, as part 2 and 3 shows, then the answer we got, x minus 5 over 3, is in fact the inverse of f of x, which is 3x plus 5. All right, so this completes our proof. All right, let's move on to question number 2. All right, let's take a look at question number 2. Same process, same instructions. For number 2, we have f of x equals x plus 3 divided by x minus 2. Okay, so we're going to find the inverse and show that our answer is correct. All right, so part 1 of the process is to find the inverse. So we find f inverse of x, the inverse of this function. So we'll start out by rewriting this function on a symbol that using a symbols that are convenient. So we're gonna use y instead of f of x. Easier to switch. So we're gonna rewrite f of x as y equals x plus 3 over x minus 2. Okay, now we're going to switch our x's and our y's. So we're going to rewrite this as, after switching, we'll have x equals y plus 3 over y minus 2. So these two x's became y's, and this y became an x. All right, so first thing you do is rewrite, then you switch. Now we're going to solve for y. Okay, we want to get y by itself. So first thing we're going to do is we can cross multiply. Put this over 1, and then we can cross multiply. Well, if we cross multiply, this bottom goes to the top, and then this one right here goes to the top. So if we cross multiply, we're going to have x multiplied by y minus 2 equals y plus 3. Okay? So after cross multiplying, we're going to distribute this x to y minus 3. So distribute this x to y minus 2. If we do that, that's going to yield xy minus 2x equals y plus 3. Okay? Now, to get y by itself, we need to collect all the terms with y to one side, and then we're going to factor out y. Okay? So to do that, I need this y to the left, and I need this 2x that doesn't have a y to the right. So to move this positive y to the left, I'll do the opposite, subtract y from both sides. Subtract y. And then to move this 2x to the right, I'm going to add 2x to both sides. So add 2x and then add 2x. All right? So here, x, y, and y are like terms, so we cannot combine. We're going to have xy minus y. And on this, the left side, the second terms are opposite, so they add up to 0. They go away. Equals, now this y minus y are opposites, they add up to 0. And then we're going to be left with 2x, this 2x right here, plus 3. Okay? Now you notice that all the terms with the y's on one side and the terms without y's on the other side. These two terms have a y in common, so I can factor out a y. So when I factor out the y, I'll be left with x minus 1. Okay, because when I divide this by y, I'll be left with x. Divide this by y, I'll be left with 1. Okay, equals 2x plus 3. Now, to get y by itself, I need to get rid of this x minus 1. To accomplish that, I will divide by x minus 1, both of them, on both sides of the equation. And my y is going to be 2x plus 3 over x minus 1. And this is the inverse, so f inverse of x is 2x plus 3 over x minus 1. All right, so there you have it. All right, so that's that for part 1. We have the inverse. Now, is our inverse correct? So that's what part 2 and 3 are going to help us accomplish. They're going to help us show if this inverse is in fact correct. All right? Okay, so let's go ahead and partition our workspace into parts 2 and 3. So let's see. Let's write it down here. So I'm going to call this part 2. So in part 2, we want to show that um, f composed with f inverse of x is equal to x. All right? All right, so what we'll do in part 2, we're going to start out by writing down what the parent function is. All right? The parent function is the original problem we had. So the parent function is f of x equals x plus 3 over x minus 2. Okay? Now we're going to compose this function with the other result. We got the inverse, 2x plus 3 over x minus 1. So to do that, we're going to have to get this function prepped for substitution. Okay, so on the left side, I'm going to clear out the x and replace it with parentheses. This parentheses will take as an argument the name of my input function, f inverse. And on the right side, these two x's will take as an argument the value of the input function, which is 2x plus 3 over x minus 1. So we have to make sure that our parentheses are sufficiently large to accommodate for that size. All right, so let's go ahead and replace the x's with the parentheses that's big enough to take the size of the input. Okay, so let's take a look at our input function for a minute. This is our input function f inverse. Let's put in the name. The name of our input function is f inverse of x. All right, as indicated here. So I'm going to be plugging in this value, 2x plus 3 over x minus 1, into this x and that x. So it's pretty big, so let's make our parentheses big enough. All right, so we may have a big parenthesis here. This is for the numerator, x right there, plus 3. And then in the denominator, make another big parenthesis because we are substituting the same thing, minus 2. All right, so the value of the input function is the answer we got earlier, 2x plus 3 over x minus 1. Let's put that in there, this value. So we have 2x plus 3 over x minus 1. All right, and then downstairs, the same thing, 2x plus 3 over x minus 1. All right, so the goal now is, can I show that this whole expression simplifies into x? That's the task, okay? All right, so what I'm going to do, let's rewrite it. What we have, this is going to be, I'll rewrite the numerator as 2x plus 3 over x minus 1 plus, since this is a fraction, I'm going to express 3 as a fraction also, all right? So I'm going to write it as 3 over 1, okay? So let's write that, 3 over 1. The same story for the denominator, okay? The denominator is going to be 2x plus 3 over x minus 1. So I'm going to write minus 2 here as a fraction also. All right, so how do we add fractions? The denominators have to be the same, right? So we have to find the LCD. So what's the LCD in the numerator of x minus 1 and 1? The LCD of x minus 1 and 1 is x minus 1, so I need to change the 1 into x minus 1. To accomplish that, I'm going to have to multiply by this term by x minus 1 top and bottom, okay? So multiply this by x minus 1 in the bottom and x minus 1 so that the denominators are common, all right? If you look at the denominator expression, the same story. Since this is x minus 1, I need to make this x minus 1. So I introduce an x minus 1 here. In order not to change the problem, do the same to the top. All right? Okay, so in the numerator, I'm going to distribute this 3 to this x and the minus 1. Okay? And in the denominator, the same thing. I'll distribute this 2 to the x and the minus 1. All right, so let's see what happens when we do that. We're going to have 2x plus 3. Let's write that again. We have 2x plus 3 over x minus 1 plus, if we multiply that, we have 3x minus 3 over x minus 1. Okay, now the denominators are the same. That's exactly what I wanted earlier. And let's do the same thing in the denominator. I'm going to have 2x plus 3 over x minus 1 minus, distribute this 2, I have 2x minus 1, actually 2x minus 2, because 2 times x is x and 2 times 1 is 2, over x minus 1, okay? All right, now let's go ahead and we're going to write the two fractions as a common fraction, all right, with the same denominator. So for the numerator, I'm going to write it as 2x plus 3 plus 3x minus 3, all right? So that whole thing divided by x minus 1. And then in the denominator, the same thing. I will combine the two fractions as one since they have the same denominator. So I'm going to write it as 2x plus 3. Now you have to be careful. You have this minus here. Since we're subtracting, it's going to change this 2x into minus 2x. And then this minus 2 minus times a minus is going to change that into a plus, plus 2. Okay? I have that divided by x minus 1. All right, so let's see what happens here. In the numerator here, you notice that we have two opposites. The 3's are opposites, so they divide out. And then If we combine them upstairs, we're going to have 2x plus 3x is 5x over x minus 1. And then in the denominator, you notice that the 2x and the negative 2x cancel out. 3 plus 2 is 5, so equals 5 over x minus 1. Okay? Now when you're dividing two fractions, you can drop, change, flip, basically multiply the top by the reciprocal of the bottom. So if we do that, we're going to have 5x over x minus 1, which is the top. And then we're going to flip the bottom over times x minus 1 over 5. Okay? So this x minus 1's divide out, and that yields 5x over 5. And then 5x over 5, we can divide the 5's out, and we end up with x. All right? So this basically shows that f composed with f inverse of x is equal to x. So that checks out. All right? So that shows that the first part of our proof is in fact correct. Okay? Now, the next task is to do the reverse composition. Is f inverse composed with f equals x? That's the question we have to answer. All right, let's go ahead and do part 3 of the proof to show that our answer is correct. So for part 3, what we're going to do here is basically show that the reverse composition is in fact true, which is x. So we're going to show that f inverse composed with f of x equals x. If we can show that the reverse composition equals x, then we are done. Okay? All right, so to do this, let's start out by writing down what the parent function is. In this case, the parent function is f inverse of x. So we found out earlier as being 2x plus 3 over x minus 1. Okay, now what we're going to do is we're going to substitute f into the x's in f inverse. So before we start that, let's get this function prepared for the substitution. So I'm going to clear out the x's and replace them with parentheses. So take this x out. We have a parenthesis here. And on the right side, I'm going to have 2 divided by. Now let's take a look at the size of what I'm about to substitute. I'm about to substitute f in there. This is going to be my input function. It's pretty big, so let's make our parentheses sufficiently large to accommodate for the size. All right, so we'll have a big parenthesis here, plus 3. Okay, and then downstairs, the same thing. This x, I'll substitute with the parentheses big enough to take this as an argument. So sufficiently large, minus 1. All right, so the value of the input function, the name of the input function is f of x. Let's put that on the left side. And the value is x plus 3 over x minus 2. So put that on the right side, x plus 3 over x minus 2. Upstairs and then downstairs, x plus 3 over x minus 2. All right, so let's rewrite this without the parentheses. In the numerator, if I want to rewrite this expression without the parentheses, I will have to distribute this 2 to the x and the 3 upstairs, okay? Because you can think of this 2 as being a 2 over 1. So the 2 goes to the top and the 1 goes to the bottom, which leaves the bottom unchanged. All right, so if I distribute 2 to the top, I'm going to have 2x plus 6 divided by x minus 2. Since this is a fraction, we can express 3 as a fraction also, so 3 over 1. And in the denominator, I do not have any value in front of the parentheses, so I do not need to distribute anything. I'll just write it as it is, x plus 3 over x minus 2. And then express 1 as a fraction, 1 over 1. Okay? All right, so in order to be able to combine these two fractions, we need to have the same denominator, so we have to find the LCD. So the LCD of x minus 2 and 1 is x minus 2, so I'll multiply this by x minus 2, x minus 2 to the denominator and the numerator so I don't change the problem. And downstairs, the same story as we did here in the previous example. When the denominator is the same, so multiply by x minus 2, top and bottom. Okay? All right, now to simplify the top, what we're going to do, like we did before over here in part 2, we're going to distribute that coefficient in the parentheses to the two values here in the parentheses. Okay, so distribute 3 to x and negative 2. That's for the numerator. And then the 1 doesn't change anything, okay? And then here we're just going to distribute the 1 to the x and the negative 2. All right? So when we do that in the numerator, we're going to have, let's see, we'll have 2x plus 6 over x minus 2 plus, now if we distribute this 3 to the top, we'll have 3x minus 6 over x minus 2. Okay? That is the numerator and the denominator will be divided by x plus 3 over x minus 2. Okay? That minus, if we distribute the 1 there, it doesn't do anything to it, so x minus 2 over x minus 2. Okay, so what we've accomplished now is we've made the denominators the same in the numerator and the denominator as we did before. So now what I can do now is express the numerator as a fraction with the same denominator. Okay, so that equals, here we're going to have 2x plus 6 plus 3x minus 6. Okay, that divided by the common denominator that we have, which is x minus 2. So divided by x minus 2. And then in the denominator, we'll do the same thing. We're going to combine them into one common denominator since they are the same. So writing them as a combined fraction, we're going to have x plus 3. And then distribute this minus to the x, it becomes minus x. Distribute this minus to the 2, becomes plus 2. And that whole thing divided by x minus 2. Okay? Divided by x minus 2. All right, so what happens here? If you look at the numerator, you will notice that we have two opposites. Okay, so one opposite. So we have 6 and negative 6 are opposites. So they add up to 0. That means they go away. And then we're going to have 2x plus 3x. That's going to be 5x divided by the denominator, which is x minus 2. Okay? That's for the numerator. Over, in the denominator, we're going to have the x's are opposite, so those ones cancel out. They add up to 0. And then 3 plus 2 is 5. 5 over x minus 2. All right, so what we're going to do now, since we're dividing two fractions, is we'll multiply the top by the reciprocal of the bottom. All right, so we have 5x over x minus 2 multiplied by the reciprocal of the bottom, which is x minus 2 over 5. Okay, so the x minus 2's divide out, as it happened over here. It will multiply across, we'll have 5x over 5. And then we can divide top and bottom by 5. So divide this by 5. 5 goes here 1, 5 goes here 1. And that equals x. So what does this tell me? It tells me that the reverse composition is exactly what we wanted, right? So f inverse composed with f of x equals x also. Okay? So since the forward and backward composition yield x, we're confident that our answer is correct. So let's write out our closing remark. Since f composed with f inverse of x is equal to f inverse composed with f of x and is equal to x, then f inverse, no, we don't have to put that. Then the inverse of x, which we found, which was our inverse, which was 2x plus 3 over x minus 1 is, in fact, is the inverse of f of x, which is x plus 3 over x minus 2. All right? So there, that basically completes our proof. So thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel by clicking up here. If you like this video, you can click like down here to let me know. Please post a comment to let me know what you think about this presentation. More clips can be found on mathgoodchef.com. Thanks again, and have a wonderful day.